What's up, YouTube? So today we got a little bit of a different video, not in my usual recording. I am currently on the road in California, as you can see, and I just wanted to do a quick little challenge while in the car. We're driving to LA right now, so while we're doing that, I thought, you know, last video covered digital inputs and outputs, and I learned a lot of things: how to use parallel circuits and how to be able to add inputs and outputs from digital. And I learned a lot of those techniques, and now I want to be able to do that for analog. So for analog inputs and outputs, basically being able to give a number that's between a high or a low value, giving a certain voltage value, and being able to measure that with like a potentiometer, like with a knob, and turning the knob. And based on that, it's going to use a lot of the same principles. It's just going to be analog this time instead of digital. So while in the car, I just wanted to do a quick little challenge, see if I can do it. And yeah, let's just get started. And here's the view right now. It's looking very nice. We're in the mountains right now. And so I brought this on the luggage here. It just has all of my circuit playground stuff, all of the tools that I use. And so yeah, I'm just gonna be working on this in the car, live for everyone to see. So here we have our breadboard, we have our pins here, we also have the knob, which is this blue knob right here, and we're just going to wire this stuff up, connect to the LED. It shouldn't be too difficult. And yeah, let's get started. Alright, and there you have it. So, it's a pretty easy wiring setup. It took me a little bit of time just because, you know, when you're in a car, everything's a little bit bouncy, and I'm recording with my right hand, so I was basically doing everything with my left hand. But, just kind of talking about the parallel circuits and what's going on here. So, we have our potentiometer here, which allows us to create a knob value, and based on how we spin it and how we turn it, it outputs a voltage value between 0 and 3.3 volts that is then sent to this pin A2, which we will read. And then we will use that value and get that value to set to our output signal pin, which is A0, and that will be able to light this light up. And what that will basically allow us to do is take the values that we have here and then send them to this LED over here. Now, another way we could have done it is to pass this through this wire here, connect it here, so that it sends this voltage to the LED. However, the problem with this is that it becomes a little bit more complex, and on the car it becomes a little harder to troubleshoot. Plus, I also wanted to really discuss in depth, like setting the value versus reading the value for analog inputs. So yeah, with that all said and done, let's get to the code. Alright, so it looks like the Bluetooth, the USB does not work right now on my computer. My computer's pretty low on charge, so it might not be communicating well, which means I won't be able to get it done on the road trip here. But I will try to make sure and see if it works at the airport. So hopefully we're able to get it done. But if not, then I will see you back at home, or I guess wherever I can work on this next, I will be working on it next. So yeah. All right, what's up? So as you can see, I'm not in the airport or on the road. I'm back at the normal spot. Good news, so bad news is the USB that I was using on the road wasn't working, so I actually couldn't connect my Circuit Playground Express. to the computer. So basically this USB port that I had next to D13 and on, that just wasn't working. So what happened was, since that wasn't working, I wasn't able to actually transfer any data, which means I couldn't put the code in. But good news is that everything is kind of working now, and the code is very similar to what I had before as well. I just made a really small change that I'll kind of talk about, that I wasn't sure about the potentiometer, which is basically just like the knob that adjusts the input value. So yeah, the code is very simple for this project. We import, of course, all the necessary packages, the circuit playground, the board, analog I/O, which basically just gives all the input and output for analog, and then time, which allows us to control how much time. This will help us when we're printing out the values in the plotter to not overflow the data. And then we create 2 pins. The cpx.pixels.brightness is 0.3. This doesn't really matter. I was in the car, I was trying to do it as quick as possible, so I just copied and pasted this here, but it really doesn't matter because we're not using the lights. So A0 is our analog output, which is basically the board sending the voltage to the light. And then A2 is the analog input, which we can see defined here with the board.A2 pin, which is basically the feedback that it receives. So now, normally the code, all I would need to do is just say A0.value, so our output value, is equal to the input value. And basically that's saying the voltage we send out is equal to the voltage we get back from the potentiometer. However, while investigating, it seems as though the potentiometer doesn't actually go from 0 to 3.3 volts, which is a value of 2 to the 16 minus 1, which is close to 65,000, but it does a very small range. So it's not the highest quality potentiometer that you could have, and because of that, I needed to create some difference here. So it's actually like the difference between a low value for the potentiometer and a high value could be visible. And I settled on the number 64764, which is divisible by 711. Basically, I took 2 to the 16 minus 1 and then divided it by a certain number, which was 85. And then from there, I was able to see what it amounted to and then use that to be able to create a value where I was able to see all of just like a range of all of the, I guess, the high values and the low values. And 64764 is kind of our base, and then we basically just see everything that comes up from it. And then if you can see the 85 here as well, just making sure that it's easy to work with, easy to manipulate, and it's something that can be used without many complex constants. So basically, sometimes it will go below this number, so I said if it goes below that number, just set it equal to 0. And then I set the value equal to diff times 85, so 2 to the 16 minus 1 minus this number here, 64,764. That number multiplied by 85 is equal to 2 to the 16 minus 1, which is the maximum voltage you could have, 3.3 volts. So this basically allows us to get this difference value and then create a new scale for it on a on this like a larger 0 to 3.3 volt type basis. And then we set it equal to that value and then print it. So I'm just going to show a little bit. We have the plotter here. I'm just going to show how it's working. So right now it's at its lowest point, and you can see there is some noise, which is to be expected because we are subtracting such a large number from a very high number as well, so there will be a lot of noise. But as I turn up the knob, you will see that it begins to increase, and now it's going to the 65,000 range, which is what we want. That's great. And then I'll turn it back down just to show kind of how it's doing, and as you can see, it's going all the way back down. So that's just a way we can control the light, and now I'm just going to show it on video just to show how it works. Again, everything I did here was all actually done in the car, except for just a very small modification to the code, basically subtracting this value and multiplying by 85. But that's something that I could have done in the car as well, so staying true to that original spirit. So yeah, now I'm just gonna show it on video, and after that I think it's gonna be a good sequel to. Alright, and so here we go. You can see the little light there, giving a preview of what's to come. So just a quick overview of the circuitry. Voltage out, and this is voltage in, and this is receiving the voltage on the potentiometer. So sending the voltage, completing the loop, and then basically seeing how much turn this is. And then this, of course, is the A0, sending the analog signal, and then ground to complete it. And that just sends light here. So that's basically the entire setup. And as I turn this knob, you see that it becomes more and more bright. And I'll just turn it the other way. And all the way to 0. So this is just a quick thing that I wanted to do while in the car in California on vacation, to keep my skills sharp, and then also to complement what I did last video with the digital outputs. This is the analog output, and I think this example really shows the power of it, where you're able to really create any value you want in between 0 and 3.3 volts for this case. And that's very powerful in specifying values and making sure that your code is sometimes robust, and can have many different states. So yeah, I hope you enjoyed, and see y'all in the next one. Peace.